Okay, you guys are not going to be fans of this assignment. It is not hard, but you're going to think, what is the point? And I can't say I disagree with you. We're teaching this because the state mandates that we teach this, okay? So don't look around back at me and say, what's the point of this, okay? Because, yeah, I don't have an answer. Go ask the state. It says find the range of the function with a given domain. Now what throws me off is I'm used to seeing a y right there. I don't know what this f of x stands for. The f of x stands for something called function notation. It is a lot less intimidating and scary than it looks. Okay, I'll just say that much. Function notation. This is how the range has to be written, okay? What you're going to do is right here, you're going to put f parentheses and all of these numbers, okay? Start with 1. Instead of putting f parentheses x, you're going to put f parentheses 1 equals. Then you're going to put f parentheses 2 equals. F parentheses 3 equals. F parentheses 4 equals. That's how it's got to be written. I know it seems kind of dumb, but yeah. Now, here's how you find out what it equals. It's very easy. Make a wall on that side of the equals. You're going to put a dot, but you don't have to circle it. Because what I have to do is punch that into a calculator. So negative 1.5. Then I hit the multiplication key, but instead of x, I'm going to put 1 in. 1, and then after the x, you got plus 4. 2.5. So f of 1 equals 2.5. That means when you put 1 in for x, you end up with 2.5 in the evaluation. Now, to find f of 2, this side is where you're operating. Negative 1.5 times, and this time instead of x you're going to put 2 in, plus 4, 1. Okay, so this is not really that hard. It's just the point is, why do we have to write it like this? Good question. That's what they want. Okay, so do it. Don't be difficult. Times 3 plus 4 is negative 0.5. So negative 1.5 times, and then the last value is 4, and then plus 4 after it. Negative 2. This is the answer. That is what they want written. Okay. Okay, f parenthesis f of x is how that's said, equals negative 2x. Make a wall, so that's where negative 2 times x minus 3. So you're going to, on this side, you're going to put f parentheses, and then the first number you're going to put in is negative 4. F parentheses, negative 2. That just means you're replacing x with these numbers. F parentheses 0. F parentheses 1.5. Sorry, that's bad writing. And then F parentheses 4. Okay? Now here we got negative 2. Times, and then the x value here, we're going to put negative 4 in. And it is 5, so f of negative 4 equals 5. Negative 2 times, and then x, you're going to put in negative 2 minus 3, that's 1. Negative 2 times, and then 0. Minus 3, that's negative 3. You kind of get the idea, I hope. Negative 2 times, and the next number is 1.5, and then minus 3. Negative 6. Some of you are like, why can't we just do a table? Well, just don't be difficult. They want it like this, okay? Negative 2 times 4 minus 3 is negative 11. And this is the answer, the whole thing. These are the range, domain, range. let's go over 2 more. Okay, g of x. I know it says g, who cares, okay? A lot of times they switch letters around. It doesn't mean anything, okay? This, by the way, walls over here, sorry about that, okay? So, know your operations. So instead of f, you're going to put g parentheses. Instead of x, you're going to put in -4. G parentheses, instead of x, you're going to put -2. G parentheses, instead of x, you're going to put 0. And then G parentheses 1.5. And then G parentheses 4. That's where those are coming from. To find out what these equal, you simply, on this side, you replace the x with these values. So 5 times -4 plus 4 is -16. So g of -4 equals -16. 5 times and then -2 plus 4 is going to be -6. 5 times 0, because that's my next number, plus 4 is 4. 5 times 1.5 plus 4 gives me 11.5. And then 5 times 4 plus 4 gives me 24. There's your answer. Okay, last one. So first off, set up how your solutions are going to work. Okay, so here's the wall times. I don't need to dot and circle because I'm not finding what x equals. X equals this stuff over here. I know what I'm going to put in for x. The circling is for when I don't know what x is. I know exactly what x is over here. All these go in for x. Okay, so h. Why they switch it, I don't know. So h parentheses, instead of x, you put -3 equals. H parentheses, now you put -1. This tells you you're putting that number in for the x. H parentheses 0 and H parentheses 8. Okay, now you just evaluate. You put -3 in for x. So -3 times -3 minus 4 is 5. -3 times -1 minus 4 is -1. So you got the same input as the output. That does happen from time to time. -3 times 0 minus 4 is -4. Then last we put 8. -3 times 8 minus 4. -28. Okay, pause the video and do the 4 problems. Hopefully, if you need some help, let me know. Then resume it when you're done. Okay, in this one you're taking notes. This is a test review. You're going to take this test on next Tuesday. Okay, it's not a lot of work, okay, but you got to know what you're doing. That's the key. It says write a function rule for the data in the table. So it says S equals. So first I pay attention to S. Where does S start at? 48. So we start with 48. From there, are you adding or subtracting? Looks to me like you're adding. What are you adding? Well, to find out what you're adding, start with your highest value and then subtract the next highest. 64, I got 8. Now take 64 minus 56, I got 8. Then go 56 minus 48, I got 8. I got 8 every time, so the number I'm adding is 8. And then I'm going to put the variable m behind the 8. But here's the deal. Your m, you can clearly see 6 minus 4 is 2, 4 minus 2 is 2, 2 minus 2 is 0 is 2. Since you're going by 2s, you're going to want to divide your 8 by 2, and that's 4. So you write it as S equals 48 plus 4m. Now the way to check your answer, you can check your answer. If you make a wall there and punch in 48 plus 4 times and pick an m, okay? Pick an m number. Let's go with 4. When I click this equals, it should be 64. Boom. That's how to check it. Okay, that's how to write a rule. S starts at 48. You're adding every time. To find what you're adding, you just minus through. That's 8. Put the variable m. I need to see that variable, but this is going by 2, so the 8 has to be divided by 2. Now, if it's a decimal, just leave it as a fraction. But 8 divided by 2 is not a decimal. It's an integer, so I put 4 out. Okay, tell whether the relationship is linear or nonlinear. This is really easy to do. You see your x going 0, 1, 2, 3. So that part's linear. Now let's look at the y. Start at 4 and minus negative 6, just like that. See how I punch that in? I got 10. Now, when I take negative 6 minus 5, I should get 10, but I don't. Then it's nonlinear. The pattern has been disrupted. Okay, now down here, going by ones, now take negative 2 minus 1, negative 3. Now take 1 minus 4, negative 3. Now take 4 minus 7, negative 3. The pattern was never disrupted. It is linear. Remember to read directions. Okay, now this is the domain range problem. This is probably the hardest problem, I would say, the one that requires the most work. I make $25 per hour at my job. My boss has a limit of 35 hours for each employee. What is the domain and range of the situation? Is the graph continuous or discrete? Now, to establish a domain and range, you're going to make an XY table. And X is our time unit, hours, and Y is money. Remember, X can't ever be money. Now, if somebody worked 0 hours, they wouldn't make any money. If they worked 1 hour, they'd make $25. That's what $25 per hour means. If they worked 2, you'd make 25 more. So that's 50. If you work 3, you'd make 25 more. That's 75. Now, you get the idea once you're through 3. But there's a limit. The limit is 35 hours. It's hours, so it goes here. So if there's a limit on hours, then there's a limit on how much money I can actually make. And you can easily, when you're given the domain limit, to find the range limit, you simply take 35 times what you're going up by, 25. Now, it's when you get the range and you have to get the domain limit where you divide and then you have to go back and re-multiply if it was a decimal. Okay, 875. Okay, so my domain is from 0 to 35. You can work anywhere from 0 to 35 hours. The money you earn is anywhere from 0 to 875. Now, continuous or discrete, put 2.5. Now, you're talking time. You can work 2.5 hours. Sure you can. It's 2.5 hours. So those exist. So the decimals also are part of the domain, making this a continuous graph. It's when we can't have decimals, only the whole numbers, where it's discrete. Okay, graph the function using a table. Okay, so first, we're going to make an XY table. And when doing a table, just pick -2, -1, 0, 1, 2. That's all you have to pick. So know your operations. Don't dot it, but don't circle it, because you have numbers you're going to put in for X. You're not solving for X. Okay, so I got 2 times -2, and then I plus 1. Got -3. 2 times -1 plus 1 is -1. 2 times 0 plus 1, I think it's probably 1. It's 0 plus 1, it'd be 1. Now 2 times 1 is 2, plus 1 is 3. 2 times 2 is 4, plus 1 is 5. Okay? Now, to graph this quadrant here is positive, positive. Remember, this is X, this is Y. This quadrant here is negative, positive. Down here, they're both negative. And right here, you got positive, negative. Now, if you don't need to do that, you don't have to. Now, the X goes from -2 to 2. So we'll go 0, and then 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay? Remember, put the number on the line. Then -1, -2, -3, -4, -5, -6, -7, -8, -9. Okay, and then the Y is this way. So 1, 2, 3, 4, 5, 6, 7, 8, 9. And then -1, -2, -3, -4, -5, -6, -7, -8, -9. You don't even have to do what I just did with the numbers. You have to get the line in the right place. So -2, -3. Okay, they're both negatives. They need to be here. So remember, this is X, so -2, -3. Right on the grid. -1, -1. So here's -1 on X, here's -1 on Y. 0, 1. Now, the 0 means you don't go this way at all. You just go straight up. We already got those down. That means you just go straight up to 1. Okay, that middle one is straight up, straight down. No. Okay, 1, 3. So here's 1, here's 3. 2, 5. And these are both positives. So 2, 5. Boom. Now you need to connect them because it's continuous. Because you can put in decimals for X. I just don't because it wastes time. But a person could put decimals in for X. So you have to connect the points because it is a continuous graph. Okay, you put arrows on each end. Okay, tell her the coordinates represent a function. Vertical line test. If you can go through 2 points with one of these vertical lines, it's not a function. Well, I can. I can actually do it in 2 places. Right there, 2 points. Right there, 2 points. That's not a function, okay? You don't need to do both of them, just one of them. Okay, number 7. If I do a vertical line here, that's 1 point. If I do a vertical line here, that's 1 point. 1 point, 1 point, 1 point, 1 point, 1 point, 1 point. That's a function then. Okay, this one. Identify the domain and range of the relationship, then tell whether the relation's a function or not a function. This is easy if you know what you're doing. XY, 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 XY. All the X values are your domain. 0, 1, 2, 1. The Y's are the range. 0, 4, 7, 6. Okay. Do you have any repeats in your domain? Yeah, you do. So that's not a function. Because of the repeated value of 1. 1 matches up to 2 different numbers, so that's not a function. Okay, domain here, range. So the domain. Okay, domain, you got -2, -1, 0, 1, 2. In the range, you got 4, 1, 0, 1, 4. This is a function. I don't care that there's repeats in the range. That's allowed. Repeats in the domain is not. I have no repeats in the domain. That makes this a function. Okay, then the last one's easy. I have 512 megabytes M of memory on my computer. That amount decreases by 3 megabytes per photo I upload. Write a function rule for the situation. This is easier than the table. So you start with the variable M. You start with 512. Then it decreases by 3 per photo I upload. So minus 3 per photo. So I put P. Okay. There it is. Alright guys, that's all I have to say on that. I hope it's been informative, and that's what your test is going to look like next Tuesday. We'll review again Monday, and you'll do a practice one on your own.